Today we are going to be looking at using the trace and the graphing feature on the TI-84 calculator to help us solve some quadratic formula problems, some quadratic applications. I'm using the notes page from lesson 15-6 from today, May 9th, 2014. Any quadratic, of course, will work on this. First thing we need to do is to turn on the calculator, and what I suggest is always go ahead and clear the calculator of anything that was done before. So second plus 712 is going to clear our RAM. Trying to figure out the best way to see the contrast. I suppose that's just going to have to do it right there. Maybe, forgive me for fooling around a little bit. Okay. The other thing that we want to go ahead and do is, since most of our problems are going to deal with something being thrown through the air, like a basketball or a football or an arrow being shot, well, we really only need to worry about quadrant 1, the positive x, positive y portion of the coordinate plane. So going ahead and setting the calculator where we only really see that part of the graph will be helpful. So go ahead and set that by hitting the window key, which is up here on the function buttons. Hit window. It defaults to a bunch of minus 10s and 10s. Well, the minimum x is just going to be 0 because we are looking at the positive section of the graph. And the minimum y, I don't know if you can tell, but on yours that will be the y min. And we're going to set that to 0. This x max feature, or x max portion, 10 is a pretty good number for it. A lot of these things, x is going to be your time, usually in these problems, and so x at about 10 seconds, that's pretty normally, done. The motion's done in 10 seconds or less. So that's good. But the y max, that's how high something usually goes. So the y-axis is usually our height, and 10 of something is usually never enough. I like the number 40 for that. And you can always adjust it later to a 50 or maybe even more if it's something going really high. And you can do that right in the middle of your problem, even after you've started entering the y equals. So, all right, so that's our initial settings, and we're going to go ahead and enter that. Now we're ready to go ahead and start putting in our formula. And the way we do that is by going, this one's worn off, but it should say y equals on the upper left-hand side. This is something we use a lot. You can use it for a regular line, or in this case we're going to use it to make our parabola, which is the arc that the ball or the arrow or the rocket, whatever, is going to fly through. So in this case we're talking about Shaq's free throw ball, and the equation is h equals 5t minus t squared plus 4. Well, we speak with the calculator in terms of x and y. So what we're going to do is just use x instead. So your equation will become 5x minus t squared, or in this case x raised to the second power. And for those of you who know the standard quadratic equation form, well, normally the x squared comes first, and that's correct for the standard quadratic form, but the calculator doesn't care. It will compute it no matter what. So I always suggest to the students that they just enter it in exactly as they see it when it comes to the calculator. The calculator will keep track for them. All right, so the final part of our problem is plus 4. All right. The formula's entered. Now I can graph it. Since I've just shown the upper right-hand corner of the graph, it's just going to show what would be the path of the ball through the air towards the goal. It's going to show the top when the ball starts curving back down, and then it's going to, on the far right-hand side over here, that's going to be the 0. At y equals 0, that means the ball hit the ground again. And so we can calculate x, which is the time, and y, which is the height. Let's look at this. The first question asks, how high is the ball after 2 seconds? Well, anything dealing with the time is really going to be easily answered with the table feature here. So we hit second and table. We know that x is our time, so at 2 seconds, the ball is 10 feet high. The next question, B, asks, when will the ball be 12 feet high? Well, hopefully we can see from here that the ball really never goes above somewhere 10 feet or so, maybe a little over 10 feet, but it doesn't ever reach 11, or we would see that there. So we can say on our ball reaching 12 feet high that it never happens. In other words, it would be an empty set. That, if you're doing a quadratic formula, would be where you try to take the square root of a negative number. If you tried to punch in 12 feet high, the whole equation wouldn't work. So in other words, we've reached the peak at 10 feet. And if you look at the other way to figure that out, and also the way to answer the next question, you can use this companion to graph called trace. Trace puts a little cursor, and you can move right and left along the line, the curve, in this case, the parabola. And so you can see here that as we reach the top, that ball really never goes above 10.25 feet. All right, that's as high as it went. Now, let's look at what is the other feature, which is, this is something called finding the zero. We could also, on this particular one, use a function. You're about to see this on a list. There'll be one called the zeros, and that's where it crosses the x-axis. And then you'll find, in this case, you could calculate what's called the maximum. That's going to tell you exactly where the vertex is at the maximum. For this one, though, we want to find where it hits the ground. It's going to hit the ground over here on the right-hand side. All right, so you're going to see the cursor and a whole bunch of numbers. Hopefully in your mind's eye you can follow along. For the first entry, we're going to need to hit second and trace again. That's going to give us a big long list of what it can calculate. We'll go to number 2, which is the 0. We want to know what happens when y equals 0, and the machine will calculate it. So we hit enter while it's highlighted on number 2. And then it asks us, is this the left-hand bound? Well, yes, this is up and to the left of the x-axis. So if you think about it, that will make sense. And we can just hit enter. Yes, that's where we want it to be. Now it wants to know what is the right-hand bound. Well, the right-hand bound is where the line passes through x and starts to become negative. And so you just want to scroll to the right. If you notice on your cursor, you're moving to the right, the ball's falling down, 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 and it's going to hit the ground right about in here somewhere. But as soon as the y equals negative, and maybe even one click past it, you can't see the cursor anymore, but right there you can see that y is equal to negative something. That's a good place for the right-hand bound. So go ahead and hit enter. Yes, enter, I want that one. Then the machine's asking us guess with a question mark. It's asking us, you see these two arrows up here? That's telling us that we have both the left hand and the right hand bound, and the machine's now asking us if we want it to guess for us, and the answer is yes, we want it to guess. So we hit enter. The machine answers for us, hey look, and you'll get some funny symbols sometimes, but y equals 0 at 5.74. One digit's usually enough. 2 digits is plenty. So 5.7 or 5.74 is how long that ball was in the air. Shaq threw it from the free throw line, and it flew through the air and would have bounced on the ground 5.7 seconds later if it didn't hit the backboard. Okay, so that's an example of tracing. You would hit second, calculate, in order to go to find a 0, or maybe you want to find a maximum, and later we can worry about some of these other things that it'll do for us. And then, of course, if it is already graphed and we want to know about a time frame, we can look at the table by hitting blue, second, and graph again, and that's going to give us the table. Again, at 3 seconds, 2 seconds, it was right around 10 feet. You'll notice that it passed through 8 feet twice. One time is at 1 second, and another time is at 4 seconds, and that would make sense if you think about the ball flying through the air. Goes past 8 on the way up, gets up to 10, maybe goes just a little past it, starts to fall, goes past 10 again, goes past 8 on the downward slope, so that's 4 seconds in. Again, 4 seconds, it hit it somewhere there towards the beginning. At time equals 0, Shaq threw from roughly 4 feet in the air. If you think about where he's shooting from his waist, roughly, that's probably about 4 feet. The ball falls through 4 feet before it hits the ground.